everybody. I wanted to record a debrief video that covers what we talked about in class about how Rabbit works. Not the whole of the Rabbit class, but the most important method in Rabbit, which is run. So let's cover a couple questions that people asked first. So some people wondered about private versus public. We've talked about this once before. When we were making the bank account objects, we talked about making your variables private, which means that only the bank account object itself is able to access and change the variable. So private means that other code in your system, other classes, aren't allowed to view or edit those variables. And the same thing applies to methods. So if we have a private method, for example, increment age, what that means is that only code inside the Rabbit can run this Rabbit command. So a Rabbit can tell itself that it's going to make itself a year older, but the simulator isn't able to run this method for a Rabbit. The simulator can't say, hey Rabbit, increment your age. So that's the difference between private and public. So as you can see, most of the, well here, let's go to the structure, which I also mentioned. So this structure tab down here is like a table of contents for the class. F is short for field, which is another name for variable. So these are all the variables that a Rabbit has. And these M's are short for method. So these are all of the behaviors or commands that a Rabbit can do. The green unlock means public. The red lock means private. So as you can see, all the Rabbit variables are private, which means no other part of this code can edit these Rabbit variables directly. And there's a couple of private methods as well. So increment age and breed and can breed. Those are all things that only a Rabbit can do. However, the main command that a Rabbit does is run. It's a little bit misleading because run sounds like the Rabbit is just going to move around, but actually, if you read the comment up here above the method, it says this is what the Rabbit does most of the time. It runs around, but it will also breed and die of old age. So let's go line by line and sort of understand what this is doing. So the first thing that happens when a Rabbit runs is it runs its own increment age method. If you ever see some aspect of the code and you're not sure what it's doing, you can hold the control button and click on it, and that will jump you to the place in the code where that's defined. And then if you hold Control Alt and then hit the left arrow, that'll take you back. So you can do Control Alt left arrow and right arrow to jump you back and forth. So as we can see, increment age adds 1 to the animal's age and then asks if that's larger than the maximum age, and if it is, we set our alive to false, which kills the animal. So let's go back here. So the first thing we do when a Rabbit runs is we get older and maybe die. Then we ask if we're alive. And if we're alive, then we do a bunch of stuff. If we're not alive, it'll go all the way down here, and that's the end of the method. So if the Rabbit's alive, we decide how many babies we want, and then this entire loop is about actually making the babies. We'll come back to that in a second. So down here on line 67, this is no longer about making babies. This is about the mama Rabbit. So let's really dig in on this line because I think this is a little confusing. So you can see the equals sign, so you know that something on the right is getting saved inside something on the left. And it looks like it's about figuring out a new location for something. So if you remember way back to when we were doing turtles for the first time, we had a turtle named Yertle, and we could say yertle.goforward 10. And I said to you this was like an important pattern that will happen forever. So the thing that's before the dot is the variable that's holding the object that you want to act. So here we've got Yertle the turtle and we want it to do something. And then this is the action that you want it to do. So that same pattern is happening right here. I've got updated field, which is an object that I want to do something for me. And then this is the behavior I want it to do. I want it to tell me if there's a free adjacent location. What that means, adjacent means next to, and free means empty. So really I'm asking the field, is there an empty location next to something? Next to what? The input is a location that I want to know, is there a free location next to it? So put it all together. I'm asking the field, is there an empty next door location to this one? And what is this variable? If you hold control and click, it takes you to the top of the rabbit class, and I see that this is the rabbit's location. So what this means is, this is the location where Mama Rabbit is. I'm asking the field to please find me an empty place that's next to Mama Rabbit, and then we're saving that location inside a new variable called new location. So this line by itself doesn't actually change anybody's location. I'm just asking the field, where's a place where I could be going? Let's pretend that there actually is an empty location next to me. So that saves here. In that case, I have this if statement that's asking, does a new location exist? And if it exists, then I run 2 lines of code. One sets the location of myself, the rabbit. The other is telling the field to please put this rabbit at the new location. So whenever you want any object in this system to move locations, you actually need 2 lines of code. The object itself, the rabbit or the fox, knows its location. But then the field also knows the location, and you have to tell both objects, the rabbit and the field. Some people were asking about the keyword this. The keyword this refers to whatever object is currently running this code. So this is in the rabbit class, so I know that this is like some particular rabbit on the field that's running the run method. And what I'm saying is, if that rabbit found a new location to go to, then I want to tell the fields to please put this object, me, the rabbit, please put this rabbit at that new location. And that's how the field knows where the rabbit is going. Okay, what's this null business about? So let's go back to new location. I said that new location comes from here, which is us asking the field if there's an empty spot next to us. What happens if there are no empty spots next to us? There are creatures everywhere. In that case, free adjacent location doesn't actually give back a location. It gives back a special value that means that there was none. And that special value is called null. So because there might not be a place for me to move the rabbit, it's possible that this actually contains null. But if I tried to set my own location to null, that would cause an error. So I have to actually use the if statement to test to see whether it's null. So that's why here I'm saying if the new location is not null, that must mean that there was a location and it's safe to move myself there. Otherwise, I know that new location must equal null. And if it equals null, then we're going to set our own alive to be false, which is a little bit weird. What we're saying is if there's nowhere next door to us to move, then we die because it's too crowded. Okay, let's wrap it up by talking about having babies. So one of the questions was, what is this line doing? Breed doesn't actually make any babies. If we look inside it by hitting Control, click, you see that it's deciding about births, and this is asking, can I breed? And then it's generating a random number between 0 and 1, and asking if that's within my breeding probability. And if it is in my breeding probability, then I generate a random number for how many babies, and that's the number I return. So if I go backwards, the breed method is just all about deciding the number of babies I'm going to have, and that gets saved here. Now let's look at the for loop. If this was 10, then this loop would be looping 10 times. If this is 100, the loop would loop 100 times. Right now it says births, which means whatever number this is, that's how many times we'll loop. And what's happening inside the loop is we make a new rabbit, and then we put the new rabbit on the field. So that's how we make babies. In a test, I might ask you what line of code actually makes a new object. You always look for running the new keyword. This is what runs the constructor, and that's what makes an object. So we're making a baby rabbit. I've got this sort of weird thing where I'm going to put the rabbit inside this storage location for baby rabbits. And then I'm going to ask the field if there's a random place next to me. And I save that here. And then I tell the new rabbit, set your location to be that random location next to the mama. And then I tell the field, put the baby rabbit at that same location next to mama. So there's a lot to think about here, but these are the kinds of patterns I want you to start to process, because you'll need to do this, you'll need to see how this happens in Fox, and then you'll need to do this yourself for your own third animal. I hope this was helpful. Please fill out the rest of the rabbit worksheet, and then turn it in. And then proceed on to Fox, and then simulator. Good luck.